Hi guys, we are beginning Unit 7 now, and Unit 7 it comprises of indicators 25 through 28, and this unit is all about equations and inequalities. It's a really good topic. So let's go ahead and talk about some of the key vocabulary after I show you the learning target or I share the learning target with you. So the learning target is I can use substitution to identify a solution to an equation or inequality. So in this one, you are not actually solving it based on inverse operations because that is coming up in the next indicators. But in this one, you have to apply substitution. You substitute something. And substitution basically means when I switch out a variable or something with a number that is provided. It's like, think about it this way. Let's say I'm absent, okay? There'll be a substitute in my class filling in for me. So the same thing when a variable is substituted by a number is taking its place in order to solve it. And that's what substitution is. This whole indicator is about substitution, all right? So let's quickly look at the vocabulary. First and foremost, I wanted to write equation up here. And we have talked about what equation means in the past because we were talking about the difference between an expression and an equation. And we had said expression was one. It could have been a numerical expression, an algebraic expression where you have numbers, you have operations. In a numerical one, in an algebraic one, you have numbers, operations, and you have a variable, but you do not have an equal to sign. And that's what an expression was. So an equation, it has all of what I just said, but is equal to something. All right. And so when we are solving, let's say I say 2 plus 3. If I say 2 plus 3 is equal to 6, that is not correct. Because in an equation, both sides have to be the same. 2 plus 3 is equal to 5. Because 5 has to equal to 5. It cannot be any other way. Inequality, on the other hand, is slightly different. So let's talk about an equation first. Remember, it has to have an equal to sign. And that's what makes it an equation. All right. So when I'm saying what is the solution of an equation, so basically the solution of an equation is a value that makes the equation true. Okay. And we're going to discuss that when I do this problem over here for you. So I'm going to provide values and then I'm going to try to solve it. And then you're going to say, is it true or is it not true or untrue? Okay. So inverse operations, these operations, they undo each other. For example, opposite of addition is subtraction. Opposite of subtraction is addition. Opposite of multiplication is division. Opposite of division is multiplication. So basically, inverse operations, they undo each other, okay? So let's talk about what we just said. We said a solution of an equation is a value that makes the equation true, okay? So let's say I give certain values, which are 3, 4, and 5. These are the values that I am providing, okay? Then I'm saying x plus 3 is equal to 7. So that is my equation. Now, what I'm going to do, it's saying value of x. So for each of these, I am going to substitute the x in that category. So in this one, I'm saying x is 3. So x is 3. Over here, x is 4. Over here, x is 5. So I'm just showing you, I've just substituted that value. And my equation is x plus 3. So I'm saying 3 plus 3 because x plus 3 is equal to 7. 4 plus 3 is equal to 7. 5 plus 3 is equal to 7. So you can see what I have put over here. Now, here's the thing. What is 3 plus 3? 3 plus 3 is 6. 6, how can 6 be equal to 7? So it is not. So this is not correct. So look, I'm substituting the values and then I'm trying to see this. 4 plus 3 is 7 is equal to 7. So yes, in an equation, both sides have got to be the same. Okay? 5 plus 3 is 8. And how can 8 be equal to 7? So that's why I put that line across the equal to sign, because 8 and 7 are not equal. I can't say 5 is equal to 6 or something is equal to 7 when it's not. Okay, only 7 can equal 7. All right, so when I see this, I'm going to put over here, is this equal? No. So both sides are not equal, so no. In this one, yes, both sides are equal. Okay, in this one again, no, these are not equal. So the only value that will have a solution to the equation x plus 3 is equal to 7 is going to be 4. So this is going to be the correct solution to that equation. Once again, remember the stress on substitution, where certain values are given to you and you have to switch out that variable with the numbers provided and then decide based on both sides have to be equal, then only can it be a solution. Like I cannot say 5 is equal to 10. That's absolutely not possible, okay? 5 plus 5 is equal to 10 for sure, because then I have 5 plus 5 is 10 is equal to 10. So that's what an equation is. Both sides have got to be exactly the same, all right? So we'll solve a few more problems after this in a minute. Let's talk about inequalities. Okay, let's talk about inequalities. So, when I say an inequality, it is basically telling me it is comparing expressions. Okay, it is comparing expressions as to what is greater than, what is less than, what is greater than or equal to, what is less than equal to. So these are all inequalities. Okay, it definitely has more than one solution. It may, like based on what's provided to you, it may have only one solution or it may have several solutions. For example, let's say I say my weight is 120 pounds. Okay, and then I ask my class, how many of you weigh less than me? And so based on the weight, there'll be several hands. Somebody might be 60 pounds, somebody might be 90 pounds, somebody might be 110, somebody might be 119. So everything, all those answers are correct because it is less than 120. If I say less than or equal to 120, then I could say 120 also in that set category. Okay, but if I say less than 120 and you write 120 is your weight and is less than, no, 120 is not less than 120, it is equal to. All right, so just want to make sure. And then there might be some of you who might be weighing more than me, because 6th grade, you definitely at this time you do overtake me in height and everything, and so you do tend to get taller and bigger and than your teachers, okay, especially the boys. And so those children will be weighing more than 120. Okay, so that's what an inequality is. There's not just one set answer to that. Okay, so solution of an inequality, I told you, is the value that makes the inequality true, and it can have several answers that are correct, several solutions. And the set of all solutions of an inequality is called the solution set. Okay, so I'm just going to use the same example that I just used 2 minutes back with the equation. Now remember, an equation, there's only one answer because I am saying something is equal to something. Okay, now look. If I say, well, actually, before I get here, let's quickly talk about what each of these phrases mean for it to actually click as to what I'm doing. Okay, so let's actually talk about what these phrases first mean, or these symbols mean. Otherwise, you'll be like, what is Ms. Joshi talking about? All right, so if I say key phrases, look at this one. And, you have always said, this is less than that. So whenever you're talking about numbers, which is greater, which is less, So this basically means you can have certain phrases. You can say is less than. Okay, so if you see that, this is the symbol. Is fewer than. That's another phrase. Okay, so these are phrases that you use for is less than. And over here, you can say is greater than. Whatever number you have here is greater than this number here. Okay, so is greater than or is more than. Okay, so these are the phrases for this that you see. So this is going to be less than this. This is going to be greater than this number over here. Okay, in this one is less than or equal to. Or equal to. So it's less than or equal to. Okay, so that's what I was saying earlier, that how many of you weigh less than or equal to 120 pounds? So the ones who are also 120 pounds would fall in this category. Okay, then is at most. Please remember these words. Is at most. So when I'm saying at most, you can be at most 120 pounds to ride this ride. Okay, so that basically means that you have to be 120 or less than 120 pounds in order to ride a certain roller coaster, for example. Okay, so that is why it says at most. Always connected to a roller coaster or something so that you can understand. You can be at most 4 feet to get on a certain roller coaster. So if you are 6 feet, please don't try getting on that roller coaster. It's going to crash. Okay, so all right. Now, and then we can have is no more than. Is no more than. So that is another key phrase for this one. Okay? Then let's look at the other one. This number is greater than, because this was less. This is less than or equal to. This is going to be greater than or equal to the other number, which is on this side. Okay? Then you can say is at least. If that is at most over here, this is at least. And guys, you see this so much, the at most and at least, and you make careless mistakes. But I'm again telling you, always think of a roller coaster. Okay? You have to be at least 4 feet to ride this ride. That means you have to be 4 feet or taller. So now it is backwards of this other one. Okay? If you're saying at most, maximum you can be is 4 feet. If it's saying at least, minimum you will be is 4 feet. Okay? So, and then here we have is, you can also do is no more than. So is no less than. Is no less than. All right? So this is basically what these symbols mean. And now that you've understood what symbols mean, I am going to go ahead and utilize this symbol in the problem that I'm about to solve, which I used an equation earlier on because I put an equal to sign. But now I'm going to change it to an inequality. Okay? So, I'm going to remove this. I'm going to use the same problem and I am going to change this part. Let me change this part because it's not an equation anymore, it's an inequality. And so equation has an equal to sign and inequality has these signs. Okay? All right. So let's make this x plus 3 and I'm going to change the equation to an inequality. I'm going to say my new inequality is this. X plus 3 should be less than or equal to 7. So 3 plus 3 is less than or equal to 7. So here's the thing. Is 6 less than 7? Yes. Is it equal to 7? No. But it is less than 7. So it says less than or equal to. So then this is definitely a solution to that. So I'm going to write yes over here. Let's look at 4 plus 3. Is that less than or equal to 7? So 7, is 7 less than 7? No, but 7 is definitely equal to 7. So when I have that inequality where it's saying less than or equal to, this will definitely work, because everything that is 7 or less than 7, including negative numbers, anything, that is going to be a solution to this equation, to this inequality. Okay, so yes, 7 is equal to 7 in this case. So yes, this is correct. Now, 5 plus 3 is less than or equal to 7. Now, will this work out? No, because is 8 less than 7? No. Is 8 equal to 7? No, because it is more. So this is not going to work. And in this case, my answer would be no. Okay, so my solution set over here would be 3 and 4. Both are correct answer choices for this one. Okay, so let's go ahead and solve a problem or two using substitution. So, all right, I'm going to go ahead and erase here. And then let's say I give you a problem which is what would, find the solution of the equation if b plus 10 is equal to 38 and p is telling you p is equal to 18. Okay, so it's asking, is this a solution? So substitution, again, because I am going to be substituting the variable with the number provided. That is very important, substitution. So that means instead of p, I'm going to substitute it what p is equal to, which is 18 plus 10 is equal to 38. But 18 plus 10 is actually 28. And can 28 be equal to 38? No. So therefore, no, this is not a solution. Or I can say no, p equal to 18 is not a solution to this problem. Okay? So definitely that's not going to work. Now if this was 28, then yes, it would have worked. Then it could have been a solution. But in this case, it is not a solution to the problem. Okay? Let's say I give you a problem in which I say that b divided by 6 is equal to 8 and b is equal to 48. Is this going to work? All right, so again, substitution, because we are substituting the variable with the number that is provided. So instead of b, I'm going to write is equal to 48. So b is 48 divided by 6 is 8. So if I divide 48 by 6, I do get 8 is equal to 8. In an equation, both sides have got to be identical because it's an equation, it's a balance. So here we are saying 8 is equal to 8. And so therefore, yes, b equal to 48 is a solution to this equation. Okay, so that definitely is a solution to this equation. So this is basically what substitution is. Let's go ahead and solve some problems with an inequality now. And if I say, again, please remember we are using substitution. So if I say x plus 1 is greater than 7. And then if I say x is equal to 8, will it work as a solution? So instead of x, I'm going to write it saying x is equal to 8. So 8 plus 1 is greater than 7. What is 8 plus 1? 9. Is 9 greater than 7? Yes, it is. Okay, so yes, x equal to 8 is a solution to this inequality, okay, because it's definitely 9 is greater than 7. All right, so that's what it means. So in this, all you're doing is you are substituting values. And let's say I'll give you another one. If I say 7y is less than 27, and then we say y is equal to 4. So if I give you something like this, we have talked about coefficients and variables. Coefficient comes before the variable. When it's written like this, it means multiplication. Okay, so please don't write 74 over here. Okay, this means multiplication. So this would be 7 times y is 4 is less than 27. 7 times 4 is 28. And 28, how can 28 be less than 27? Because this is more. So this doesn't work. Okay, so no, y is equal to 4 is not a solution to this inequality. Okay, it's not a solution to this inequality. So if I say let's say I give you a problem and I say we'll solve the equation 14x is equal to 116. Okay, and then I say he got a solution of x is equal to 5. Okay, so he got the solution. So we'll solve the equation 14x is equal to 116. He got a solution of 5. Is he correct? You must show substitution to check your answer, and you must show how you have used substitution. Otherwise, you will not get credit. Okay, so we're doing 14x. That means 14 times 5 is equal to 116. And then if I do 14 times 5, I get 4 times 5 is 20. 5 times 1 is 5 plus 2, 70. So I actually get 70. And how can 70 be equal to 116? So that is not correct. So Will did not get the correct answer based on what he got, because if you're getting a solution of 5, it would actually be 70 and not 116. So make sure that you are actually showing these steps, because substitution, once again, guys, can't stress that enough. That is what this indicator is about. But anyways, this is on the equations. Okay, something is equal to something, and inequalities. And then everywhere you are provided a certain value, and you have to substitute that value for the variable in order to solve it, or just to make sure that you are fitting the equation or the inequality based on what is provided to you. Make sure that you really understand these key phrases, because you're going to see this over and over again from now on. All right? Okay, guys, have a wonderful day.